Hi, everyone. Welcome to the first video for week 7, our last week of the course. And this week, we're going to be talking about two things, regression and correlation and the ANOVA test. This video, we're going to focus on the regression equation. If a data set produces a scatter plot that looks like it's potentially linear or approximately linear, we can fit the data to a straight line. So last week, we learned the first step in our regression and correlation analysis, which is to make a scatter plot and to look at the shape of the data and the apparent strength and direction. Does it tilt up or down? Are the points closely packed together or really spread apart? If that scatter plot looks linear, we're going to describe it or model it using a line of best fit. We call this best fit line the least squares regression line, or sometimes just a regression line or least squares line. In your book, it goes over some of the process of how to do this by hand. However, in 2023, no one does this process by hand. So we're going to use technology to graph the line of best fit and find the equation to describe that line. The equation that describes that line of best fit is called the regression equation. And the regression equation is important because it allows us to make predictions about the population as a whole. So to find the regression equation on a TI-84, you're going to enter your data into lists. So your X values go in list 1 and your Y values go in list 2. And it's important that you keep them in the same order that they were in the data table, because remember that those X and Y values are paired together. Each pair of values represents a single point in the scatter plot. So we need those X and Y values that are tied together to stay together in the calculator. We're then going to go to Stat, Calc, and we want option 8. Lin reg a plus bx. And we want a plus bx because that's going to spit the equation out in the same form that your textbook is using. You'll notice option 4 says lin reg ax plus b, which is also a valid way to do it. And it will give you the same equation with these terms in the opposite order. We're using option 8 because, again, that matches your textbook. For the prompts, X list should be L1, Y list should be L2, the frequency list should be blank. And if you are interested in creating a scatter plot on your calculator and you want to see that line plotted, you want to pull up Y1 for that store regression equation. If you're not going to do graphing on your calculator, then you can leave this store regression equation prompt blank. If you're interested in graphing on your calculator, to pull up that Y1 variable, you're going to go vars, move to the YVAR menu, select option 1 for function variables, and then select Y1. And that's going to store the equation that the calculator finds in that variable so we can use it to graph. GeoGebra is a little bit nicer in that it automatically stores the equation it produces, so a little bit less work. You do need to enter your data in GeoGebra, just like the calculator, but you need to create a list of ordered pairs. So it doesn't want the X and Y separately, it wants each point. So first point, comma, second point, comma, third point, and then that whole list surrounded by curly brackets, and you have to give that list a name. Once you've entered your data, you're going to call the linear fit function, which is called fit line. So fit line, and then in parentheses, whatever you named your list. A note that GeoGebra always outputs their equation in slope-intercept form, ax plus b. To match the form that you're going to see in the solutions in your textbook, just flip the order of those terms. So switch it so that you've got b plus ax, and that will match the answer in the back of the book for your textbook. Okay, let's go ahead and do 2 examples really quick, one for each method. For example 12.6, it says a random sample of 11 statistics students produced the following following data where X is the third exam score out of 80 and Y is the final exam score out of 200. Find the regression equation and create a scatter plot showing both the data and the least squares regression line. So we can see we have a data table here. We're going to go ahead and use a TI-84 for this problem. So I'm going to pull up my TI-84, and I know that the first thing that I need to do is I need to enter this data into 2 lists. So stat, enter. I've got some old data in here, so I'm going to clear that out. And then we're just typing the X's and Y's in the order that they show up in the table. So you can see here I've entered the data in those lists. You can also see if I go up to that last data point, I'm on box 11, which is good. We know we have 11 data points, and I can see that last data point, 69, 159 is paired. The data point above it is paired. So I've probably entered this data correctly. Our next step, we're going to go stat. We're going to go over to calc, and then we want option 8. Lin reg a plus bx. I'm going to hit enter. And we want list 1 for x, list 2 for y, frequency list is blank, and I'm going to store this regression equation. So I'm going to press vars, and then I'm going to go to y vars. I'm going to select function and y1. And then I'm going to go down to calculate, and you can see that it spits out, for me, 4 values. For those of you who haven't used linear regression on your calculator before, it may just spit out those first 2, A and B. So what it's giving us is it's giving us the slope and intercept for our equation. So let's go ahead and write that down. So the resulting equation, we're going to write y, and my instinct is y prime. I think your book uses y hat for linear regression equations. And then A comes first. I can see that in the model here. So minus 173.51. I'm going to round it to 2 decimal places. That looks good. And then plus, and then B times X. And B is 4.83 if I round that, times X. So the number in front of the X, that's the slope of my line. It's positive, so this line is tilting up. And then this is our y-intercept, which is the initial value. This is where our line is going to cross the y-axis. So it's crossing way down at negative 173.51. I'm going to show you really quickly how to graph on your calculator now that we have that data and that regression equation stored. So we're doing a plot that is specifically a statistics plot. So instead of just clicking y equals, I'm going to click second and y equals to access stat plots. And you'll notice there's a whole lot of off, off, off by default. But I want stat plot 1 on. I'm going to click it just so we can see what that looks like. So when you click that, you get the choice to turn the graph on or off. And then you get a choice of different types of graphs. The default is a scatter plot, but you can see some familiar graphs that we've talked about. There's a histogram, there's some box plots, so lots of other options. It's then going to ask you where your data is, and it defaults to where we put it, list one, list two, and then the type of mark you want to use, a dot, a plus, or a tiny dot. I prefer the default, so I'm going to leave it that way. And I'm going to click graph. And my graph comes up nice and pretty. Yours may not. If yours is not visible like this, you're going to want to click zoom and scroll down until you see zoom stat, which is option 9. And that's going to recenter your graph so that the data all fits on the screen. So this line in our calculator is this line here, 4.83x minus 173.51. And we can see from this graph that a decent amount of our data is pretty close to that line. And then we've got some points that are further out. We're going to talk in a later video about how to describe the strength of this relationship. But for now, I want to do another example with GeoGebra. So let's go ahead and clear that and do example 2. This came from your textbook, try it 12.6. Says scuba diver have maximum dive times they cannot exceed when going to different depths. The data on the right shows different depths with the maximum dive time in minutes. Use your calculator to find the least squares regression line. And then we can see here the x values are the depth that the diver is diving in feet. And then the y time is that maximum dive time in minutes. So let's go ahead and pull up GeoGebra, and we're going to start that process. And we know for GeoGebra, we want to create a list of ordered pairs. So I'm going to, I'm going to start with curly brackets. And actually, I'm going to start with a name. I'm going to call it A, curly brackets. And then I'm going to enter those data points, x, comma, y, as ordered pairs, 50, comma, 80. And then I'm going to move outside those parentheses, put a comma, and then type my next point, 60, comma, 55. And we just keep going down that list until all the ordered pairs are entered. And once all that's done, you just press enter and it stores that list in memory. And then we're going to type fit line and the list name. And it gives us negative 111x plus 127.24. So this number in front of the x is the slope. This number at the tail end, this constant, is our y-intercept. And that's correct. However, if you were to check your answer in the back of the book, it wouldn't have it written this way. It would have it written with the y-intercept first. And you would see y hat equals 1, sorry about that, 127.24. And then there's a minus, so minus 1.11x. The nice thing about GeoGebra, I'm going to clear this drawing so we can expand the window, is that you'll notice there's an empty circle next to the data. If I click that, both of these things are now graphed somewhere in the coordinate plane. I'm going to go up here. I know my y-intercept is at 127 and my first data point's at 50. So I need to go up and over to find my data. So here's 50, and I know 50 and 80. So I need to be way up here before I start seeding data points. There we go. So 50 and 80, we can see our 60 and 55, and you can see all those points in green and that fit line in black. So the nice thing about GeoGebra, it's a little bit harder to get the data in. It's a little bit more picky about the format, but it auto plots everything. You just have to make sure those circles are clicked so it shows up on the grid. Okay, that's it for our first video. If you have questions, please contact me via email, text message. I have office hours Tuesday, Thursday, and Friday, because Friday is the last day that I'm going to be accepting work for this course. I hope you have a good last week, and I will see you in the forums.